sir.
Hi, Aditya. Has Shreya joined the call?
Don't think so.
Is Shreya there in the call? Yeah, Shreya joined.
Yeah, just join.
Okay, great. Okay. Can you see the screen now?
Yeah.
Okay. So I think last class we were talking about the convergence test, right? And I think I stopped at the limit comparison test, correct?
Yeah.
All right. So we covered the nth term test. We covered the P series test. We covered the comparison test. We covered the integral test. So now we are going to start with the ratio test. So let's start with the ratio test. The ratio test. Okay. Again, in the ratio test, let's say you have been given that summation an is a non-negative series. This is a non-negative series. I've already explained what's the meaning of a non-negative series. A series where all the terms are positive.
Yeah.
Okay. And let the limit of n plus 1th term to the nth term be equal to L. Okay. Now this test says that if your L is less than 1, the given series converges. Okay. So this L is a finite number, and if this number is less than 1, the series converges. And if L is greater than 1, the series diverges.
So equal to 1?
Okay. And equal to 1, the test fails. So the test fails, that means it is inconclusive. Okay. Now, many times it's a good practice to take the mod of this term. Normally, we talk about mod of an plus 1 by n as n tends to infinity, and I find this value L. Okay. But since we have already told that the series is non-negative, we actually don't need this mod. Okay. But many times you will see that they'll use the mod also sometimes. Doesn't make much of a difference to the test. So remember, the ratio test, you take the n plus 1th term to the nth term ratio and find the limit of it as n tends to infinity. If the limit, which is a finite quantity L, if that is less than 1, it is a convergent series. If it is greater than 1, it's a divergent series. But the test doesn't say anything if your L becomes equal to 1. Okay. Let's take a few questions based on this. Does summation 1 by n factorial converge or diverge? Okay. So if I have to find this by using our the ratio test, what I'll do is I'll write the an plus 1th term, which is 1 by n plus 1 factorial. An is 1 by n factorial. Correct. And now I'll find the limit of an plus 1 by an, that is 1 by n plus 1 factorial, divided by 1 by n factorial will be like this.
That's
that
n
is nothing but n plus 1. And as n becomes very, very large, this term will become 0. So since 0 is less than 1, remember, it would be a convergent series. It would be a convergent series.
Yeah.
Is that fine?
Yeah.
Okay. Let's try another one. Does summation n to the power n by n factorial converge or diverge? Try this out. Try this out.
Yeah.
So it'll be n plus 1 to the power n by n to the power n, right? After you. Then after.
So what is an plus 1?
N plus 1 to the power n plus 1 by n plus 1 factorial.
Right? Okay.
Into n factorial by n to the power
So
n.
an is n to the power n by n factorial, correct?
Yeah.
So let's find out the limit as n tends to infinity of an plus 1 by n. Okay. And that would be limit n tending to infinity
N plus 1 to the power n.
n plus 1 by n plus 1 factorial by n to the power n, and we'll have n factorial here as well. Okay. So if I'm not wrong, it gives you limit n tending to infinity. This will cancel with an n plus 1 over here. And one
So
of
it'll
the
be
n
n
plus
plus 1
1,
to the power n.
yeah, so one of the n plus 1 will go off. So it'll give you
By
n
n
plus
plus
1 by n to the power of n, correct?
Yeah,
Yeah.
exactly.
Which is nothing but 1 plus 1 by n to the power of n. Now this type of limit is actually termed as 1 to the power infinity form of limit. And I think I've done a similar type in the class as well.
No, it started.
Yeah. So this answer is going to be, now in this case, the answer for this is E. Do I need to show how it is E?
No, we did it.
Yeah, you would have done this in your NCRT also. Some basic limits are mentioned. One of them is this. Okay.
Wait, why is it e?
Why it is E? Okay. So in this case, what do we do is we'll consider this limit to be log, to be L, sorry. And we take a log on both the sides. So let's take log to the base E on both the sides. Log to the base E. Okay. So this becomes limit n tending to infinity n log 1 plus 1 by n. Now what do we do is we take 1 by n as, let's say, y. So this term becomes limit y tending to 0. This will become ln 1 plus y by, can I write this n as this divided by 1 by n? Okay. And this entire term is log of L. This is a limit which you have already seen before, Aditya.
Yeah.
Ln 1 plus x by x tending to 0.
Yeah.
That's 1.
That's
So
1.
log L to the base E is 1. So L becomes E. Okay.
E2. Yeah.
Now E, as we all know,
So it diverges. Right?
right. E, as we all know, is 2.71828 da 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 da, which is greater than 1, and hence this particular series will diverge. So it's a divergent series.
So but you said it's of 1 to the power infinity form. So but that doesn't give you e, right? Like
Why not? Who told you it doesn't? 1 to the power infinity means this 1 is not exactly 1. It's tending to 1.
Okay. Yeah.
Again, 0 by 0 is not exactly 0 by 0. It's tending to 0 by tending to 0.
Yeah.
Right?
Yeah.
So with this, we come to the end of our series test. Now we'll be starting with alternating series.
So did you say anything? My internet connection. When did you say anything before this?
I said that we have ended the tests on convergence. Now we are going to start with alternating series.
Okay.
Now what's an alternating series? Alternating series is basically where you have alternating plus minus signs between the terms. Okay, something like this. A1 minus A2 plus A3 minus A4, etc. Okay, let's say it goes to infinity, and there in between you have a term minus 1 to the power of k plus 1 AK. This is called an alternating series. You can abbreviate this series like minus 1 to the power k plus 1 AK, k going from 1 to infinity, you can say. Is that fine? Remember, we normally choose our AK to be positive. So this sign are external to it, and all these terms themselves are positive terms. Okay. One simple example of this would be 1 minus half plus 1/3 minus 1/4, and so on. Okay, like this. Okay, where n tends to infinity. This is called an alternating harmonic series. This is an alternating harmonic series. Okay. So we are going to take a test for these kind of series as well, which we call as the alternating series test. So listen to this test very, very carefully. The alternating series test. This alternating series test says that an alternating series converges. An alternating series converges. Okay, if it meets the following two criteria. Number one, its an plus 1 term should be lesser than anth term for all n. Remember, I am still repeating this. AK is taken as positive for all k. Okay, so don't think that okay, they have to be, one of them have to be greater than the other. They both are positive, by the way. We are putting external signs separately. So remember, I've written over here categorically that all terms are considered to be positive over here. Okay. And second is the limit of the nth term as n tends to infinity should be 0. Is that fine? Okay, so let me ask this as a question to you. Does the series minus 1 to the power of n plus 1 by n, we just now saw the series was called as the alternating harmonic series, right? Does this converge? Does this converge or not? Converge or diverge? Answer this. Use the two tests, use these two criteria mentioned.
The first one, it passes.
So an will be what? An will be 1 by n, right?
Yeah.
An plus 1 will be 1 by n plus 1. So an plus 1 is less than this. That's obvious. So since, or for the reason an plus 1 is less than 1 by n, it passes the first test.
So it converges.
And not only that, the limit of an, which is 1 by n as n tends to infinity, is 0. So both the conditions, yeah, so it is a convergent series. right? And it's quite surprising because the harmonic series was not converging, right? But the moment you make the signs alternating between the terms, we get a convergent series.
Yeah, that's what I was thinking.
Okay.
Yeah.
Now, there's something called absolute convergence and conditional convergence. Let's look into this. Absolute convergence and conditional convergence. What's an absolute convergence? A series with a mixed sign or an alternating series is said to converge absolutely if the series obtained by taking the absolute values of the term converges. Correct? See, let's say you have been given a series like this. Okay? Getting the point?
So that's just taking mod of everything.
Yeah. If you take mod, you lose all the signs. That means if this converges, then even this will be convergent, and those type of convergence would be called an absolute convergence. I'll give you an example. I'll give you a very simple example to understand this. See, we have already seen that. Oh, I've run out of the sheets. Okay. So we have seen that 1 by 1 square, 1 by 2 square, 1 by 3 square, da 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 da, till 1 by n square. This is convergent, correct? Let's say goes to infinity. By the way, if you remember, it was actually 1 by n to the power p, correct? And p is greater than 1. So this is a p series, correct? P series is known to be convergent when p is greater than 1.
Yeah.
Correct? So even if you take the alternating sign between the terms, let's say like this, that means minus 1 to the power, let's say n plus 1 by n square, da 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 da. This will also be convergent, and such convergence would be called an absolute convergence. Are you getting this point?
So, but anyway, even when you evaluated, say, the one we did for the alternating harmonic series, the sign didn't matter to us like at all, even when we solved it.
I didn't get you.
Like when we use the alternate series test for the alternating harmonic series, the sign didn't matter at all in how we solved it, right?
No, that convergent is different. Now that convergent itself can be of two types. It can be absolute, it can be conditional. So I'm not questioning its convergence. Okay. If this test is satisfied, it is convergent. Okay. Now the question may ask you what type of convergence it is. Is it an absolute convergence or is it a conditional convergence? So all you need to check for convergence of an alternating series is whether these two criteria are met.
Yeah.
Okay. Now, in addition to it being convergent, you are trying to identify the type of convergence. It can be absolute, it can be conditional. So when do you call it as an absolute convergence? It is called an absolute convergence even if you take the modulus of all the terms in that series, and that series is also convergent, then that alternating series would be called as absolutely converging series.
Yeah.
But try to take an example like this: 1 by 1, 1 by 2, 1 by 3, etc., which is a harmonic series, right?
Yeah.
We know from our experience that this diverges, right?
Divergence.
But just now I took an example. Where I showed you, where was that example? Yeah, this example, and we concluded that it was convergent. Correct. So now this convergent would be called conditional convergent. Right? So this diverges, but this guy converges. Okay, this guy converges, and this convergence will be called as a conditional convergence. Just for your information, because the question can directly be targeted at type of convergence also. Okay, can we take some question?
Yeah, but there's no test for alternating test series test for divergence. It's just that if these two conditions are not met, it's convergent.
Yes, yes. Any one of these two conditions is not met, it is divergent.
Divergent,
Yeah.
sorry.
Yeah.
Yeah.
Let's take questions. Determine whether okay.
Mm-hmm.
Determine whether this particular series converges absolutely or converges conditionally or actually diverges. Which of the three options?
Diverges, right?
Yeah.
Absolutely, it diverges because as you would see, the limit of an
Is what? Is
as
one.
n tends to infinity is actually, as you rightly pointed out, it's 1. So if you find this limit as n tends to infinity, we need to divide by n square. I'm trying to copy Sal Khan of Khan Academy. So it will be 1, right? I somehow feel that he puts on that lot of accent. Sometimes it makes very difficult to understand what he's saying.
But he was raised in US. So, yeah.
Oh, he's actually a Pakistani, right?
Yeah. No, Bangladeshi, I think.
Oh,
No,
my.
Pakistani.
Okay, Pakistani.
Yeah.
Okay, and Sal Khan. Next question is determine whether this is cube root of n plus 1, okay, n equal to 1 till infinity. Determine whether this converges absolutely, converges conditionally, or diverges. Does this converge absolutely? Does this converge conditionally, or does it diverge?
Converges absolutely.
What do you think, Shreya? So I think when Aditya you say it converges absolutely, that means you are trying to claim that this particular series converges, right?
Yeah.
Do you really think so?
Wait.
See, try to compare this with the P series.
Oh.
Okay, now in this case, you realize your P is less than 1.
Yeah.
So it diverges, right?
Yeah, it's conditional.
Correct?
Yeah.
So if it diverges, that
Then 1
means
by n
it
plus 1 to the
cannot
power.
converge. It can my required series will never converge absolutely. It can either converge conditionally or it can itself diverge. Correct?
Okay.
Correct? So
Yeah.
only two possibilities are there, either first one or second one. Okay. So first one is ruled out. Now let's check the alternating test series condition. That is an plus 1 less than n? That means is n,
Yeah, it is.
n plus 1 plus 1 cube root less than 1 by n plus 1 cube root? Yes, this is correct.
Yeah.
This is true. This is true because the base here is heavy. Correct.
And limit is 0.
And what about the limit n tending to infinity of 1 by n plus 1 whole cube? Absolutely, this is going to be 0. So yes, it is converging. Okay, it is a convergent series, but because the positive counterpart is divergent, we will call it as conditionally convergent.
So, but this is 1 by n plus 1 to the power p, right? So we just say that because 1 by n to the power p is divergent, and that's a lesser function, therefore that's also divergent.
No, again, see, what did I say? If you start putting n value as 1, you get the first term like this, second term like this, third term like this, like so on. Correct?
Yeah.
Now, do you recall the theorem where I said that even if you exclude or include certain terms, it doesn't change the nature of the series?
Okay, so you exclude the first term and it becomes 1 by n.
Right. So we know that this is divergent, and if you remove this also, if you remove this term also, the remaining series will still remain a divergent one. Doesn't make any difference. Even if you remove 5, 6, 10, a finite number of terms, it will still remain divergent. It's like you're pulling out few drops from an ocean. Doesn't reduce the ocean by a marginal quantity. Yes or no?
Yeah.
Okay. So the answer here is this particular series is conditionally convergent. Next important thing that we are going to talk about today is approximating the limit of an alternating series. Approximating the limit of an alternating series. Okay. Now try to understand this through a simple example because the theory is very confusing in this. Okay. See, when you're trying to sum up a alternating series, let's say I give you a series like this, summation of minus 1 to the power of k plus 1 by k from 1 to infinity. Okay. So we know that it's an alternating harmonic series, correct?
Yeah.
Okay, it goes like 1/2, 1/3, minus 1/4, plus 1/5, minus 1/6, and so on, correct? Let's say I call this series as S. Okay. Now, if you try to approximate these series by taking a certain number of terms, let's say I take the first 6 terms. Okay. Normally we call this as S6. Okay.
Yeah.
Now, the theorem says that if you want to approximate an alternating series by taking S6, remember that there will always be an error in this, which would be actually lesser than the first omitted term modulus, which we call as R6. R6 is basically nothing but the first omitted term in that series?
Wait, what do you mean omitted term?
Omitted term means, since I considered S6, ideally if I would have continued, I would have got 1 by 7, right?
Yeah, so that's the seventh term, right?
This is the first omitted term in that seventh term that is omitted because we were asked to only take S6.
Okay. Yeah.
Why is it? Okay, yeah.
Okay.
So it's just called R6, but it's basically the seventh term.
Actually, this is called R6, and this R6 is actually lesser than that. We say mod of this is lesser than that omitted term, which in this case is your 1 by 7. Why am I erasing this? Yeah, 1 by 7. Are you getting this fact?
Yeah.
Mm-hmm.
Okay, I'll try to explain this with a simple example. In this case itself, if you're asked what is the limit of this sum, right? Means if you ask to enclose that sum within two boundaries, okay, and you're only allowed to take the first 6 terms in your account while trying to estimate the value of S. Okay, so think as if you want to estimate the interval in which S lies. In which S lies only by using the first 6 terms. Okay, I'm taking just a simple example in this case. Okay, so then this example says that your S will actually lie between S6 and S6 plus mod of the omitted term, where n here is 6, so that will be your 7th term. So I'll make this n as 6. Are you getting this point?
Yeah.
So can you all use your calculator and tell me the value of this, the first 6 terms? Even I can use that. Let me just use myself. So 1 minus half plus 1/3 minus 1/4 plus 1/5 minus 1/6. Okay, so the sum as 6 comes out to be 0.616. Okay, so this series will approximately lie between 0.616 but will be lesser than 0.616 plus 1 by 7. That's 0.759. Are you getting this? So this harmonic series will somewhat lie in this range. Are you getting this point? Now you would ask,
so
if I would have taken more. Yes.
Do you choose the Do you choose the number of terms, or will they tell you?
No, they will tell you. They will tell you. They will tell you. Okay. So let's say you would have claimed here that, sir, had you chosen 7 terms, then this range would have been different. That range would then be a subset of this. That means you come more closer to your S. Right? So let's say I take the 7th term. Let's say I want to approximate it between 7 terms. So I would say S would lie between S7 and S7 plus mod of the 8th term. Mod of the 8th term.
Yeah.
So if I just include a plus 7, let's see what happens. Minus 1 by 7. Okay. If you do minus 1 by 7, this would come out to be, it was minus 1 by 7 or plus 1 by 7?
It's plus 1 by 7. Okay. So it's between 0.759 and
plus 1 by 7. Okay.
0.759.
And it will be divided by 8. So it will say 0.759
884
and 0.884. Okay. So the more number of terms you take, the more closer you will be to your final answer.
Yeah.
Mm-hmm.
Okay.
Mm-hmm.
Let's take questions on this. So basically what I'm trying to say from the previous slide, that the error that you get will always be less than the omitted term.
Yeah.
Are you getting it?
Yeah.
It's very important. Let's say a question that can be framed on this. Using the alternating series error bound, use the alternating series error bound to determine how many terms must be summed to approximate to 3 decimal places the value of this series. I'll read the question once again. Use the alternating series error bound to determine how many terms must be summed to approximate to 3 decimal places the value of this S. Okay. Now, what is the meaning of that? The meaning is, let's say I summed it till X number of terms, or let's say M number of terms, correct? Okay. And I got some value. So let's say AM, I summed it till AM terms, okay? And let me use this sign as well, M plus 1. And I got some value SM. Okay. Now, which term is omitted? AM plus 1 term is omitted.
Yeah.
Correct. If the mod of this term, in fact, we always take it positive, so there's no point writing a mod because sign is always external. So this is what I'm calling as AK. So if AM itself has a value where the first 3 decimal places, they're asking you to approximate it 3 decimal places, right? That means the first 3 decimal places don't change. That means it should have a number appearing here. It should have a 0, 0, 0 appearing over here.
Why does it necessarily have to have a 0? Can be any number.
Approximate to 3 decimal places means whatever has happened over till SM, the error here, which is your AM plus 1, it should not change the first 3 significant figures here. That means it should not change the first 3 decimal places over here. Then only your S will be correct to 3 decimal places, isn't it?
Correct. Yeah. Yeah.
Is that clear?
Yeah.
Okay. So you tell me after which term your AM plus 1 will start becoming 0.00 something. So lowest of this, I'll take it as 1. So when is this lesser than this? That's what I'm trying to say. So basically you are trying to find out M plus 2, right? This will become M plus 2, correct?
Yeah.
When is M plus 2? Sorry, this is M plus 1 only because
it's M plus 1. Yeah.
M plus 1, I'm sorry. Yeah. When will this square become lesser than 0.0001?
It has to be less than 100.
See, Shreya, have you understood this? Why I'm taking 3 zeros? Let's say till SM, let's say, assume hypothetically, let's say till SM the sum was 0.7438. Okay. And this error, this is actually your error bound. The upper bound on the error is this. Okay. So if this error is 0.0001, And when you add this or subtract this, it is not going to influence my first 3 decimal places, right? Because when you add it or when you subtract it, whatever you are doing, it will remain 0.743, and this will change depending upon whether you are adding or subtracting. So at least leaving this term, at least these 3 would be fixed.
Right.
So what if it's like 0.99, like 9999 plus 0.0001? Then it would increase, right, number of places.
So we add this error actually, right?
Yeah. So if you add 0.9999.
Oh, you're saying that if there's a 9 over here.
Yeah. Across all 4 of them. Like 9999 plus 0.001, that would give you 1, right? So wouldn't that be wrong? Like
that's actually a good question, but I've never seen a scenario like that coming up. Whenever they give a question, they assume that not all the series is 9. Okay. Not all the numbers is 9 actually.
But like mathematically,
even if the last digit is 9, it'll still make a difference. For that matter.
Yeah, it may change this. So ideally speaking, yeah, you would have, but that would be like, being cautious with that particular series. So you're taking some hypotheticals, you're taking some extreme scenario and trying to be over cautious.
Yeah, but like for the sake of the math, it could be possible.
Yeah, it could be. So actually it depends. You should actually check, but normally the value of m is so large that it is not literally possible to sit and add them in the examination hall.
Yeah.
So we try to just take the optimal normal scenario rather than taking an extreme scenario.
Yeah.
Cool.
Okay. So basically, m plus 1 square should be greater than 10,000, correct?
Yeah. So m plus 1 should be greater than 100.
Yeah. M plus 1 should be greater than 100. That means you should take more than 99 terms if you don't want your first 3 decimal places to change.
Okay.
Let's see whether if you have a question on this.
So wait, don't change the slide. Yeah, you can change it.
So the answer is just 99 terms. Right?
Yeah. Next question is, if there is a series like this, okay. So this is actually a series for tan inverse 1, which is actually pi by 4. Okay. So if you go all the way till infinity, this value will approximately come out to be pi by 4. Now the question is, if this series is used to approximate pi by 4 with an error less than, so your error should be less than 0.001, then the smallest number of terms needed is, option A 100, option B 200, option C 300, option D 400, option E 500. So remember, the maximum error possible Rn will always be less than an plus 1. This is the maximum error possible, which we call as the remainder of the series. That remainder of the series will always be less than the first of the omitted terms. See, actually it happens like this: S1, S2, S3. Let's say you stop at Sn, okay? Right? Let's say you want to calculate this. Now, whatever is the remaining term, we actually call it as Rn, the remainder term. This remainder term modulus will always be less than the first term in this particular remainder. Basically, you stopped here, right? So after that, it would have been like this. Had the series continued, it would have been like this. So this will be lesser than the first omitted term, always. This is what this theorem says.
The first omitted term is called the error bound, right?
Yes, and this is called the error bound. Why it is called an error is because when you add this up and you subtract it, I should not have written S1, S2. Actually, I should have written A1, A2. My bad. So when you write it as A1 minus A2 plus A3 and so on till whatever is your AN. Okay. So this is Sn. So the difference between S and Sn, which is actually your Rn, will always be less than the first omitted term. That's what this series says. So what is the general trend of the denominator?
1 upon 2n plus 1.
If I write a n term, it's 1 by
2n plus 1.
2n minus 1, na?
Yeah.
Okay. So let's say the omitted term is an plus 1, which is 1 by 2m plus 1. This error should be less than 0.001. So 2n plus 1 should be less than 1000. Yes or no?
Yeah.
Yeah. So what is the answer telling me?
So 2n plus 1 is greater than 1000.
Oh, I'm sorry. Thanks. So 2n should be greater than 999
by 2.
So n should be greater than 999 by 2. So next number after this is 500. So I have to at least take sum till 500 so that the error in calculating the series is less than 0.001. So if you the moral of the story is if you take 500 terms like this, you can expect that the answer that you get is not far away from the original answer by more than 0.001.
Okay. Yeah.
Are you getting the moral of the story?
Yeah.
So,
this is the most
question.
confusing part of the alternating series. Yeah.
You had written the an term is 1 upon 2n minus 1, but 1 will not satisfy that, right? It will be minus 1.
Why not?
So if you put n as 0,
yeah, n cannot be 0. Position of the term is always a natural number. This is your first term.
So you took
second term.
So in the solution, you took it as 2n plus 1.
Because the error is n plus 1, na?
Okay, sir.
You're summing till this term, but the error will be the first of the omitted term, correct?
Yeah.
This is what I wrote. You're summing till n terms, and the error, whatever is left, cannot be greater than the first omitted term. So R will always be less than an plus 1.
Yeah.
Understood, Shreya?
Yeah, I got it.
Okay, let's take another question. Yeah, let's take this question. We have summation of this. Okay, and this series is approximated by the sum of first 300 terms. This is, you're trying to approximate it. See, this is a never-ending series, right? So you want to approximate this sum, and you try to approximate it by summing first 300 terms. Okay. What is the max error that can happen in your by your approximation? So what is the error bound of your approximation? Option A, 0.001. Option B, 0.002. Option C, 0.005. Option D, 0.01. And option E, 0.02. So the error bound is which of the following?
So just to say,
I don't think so. It should take so much of time. This is your error bound, right?
so is it is it D? Wait one second, let me go back.
So 1
Yeah,
by
is it D?
903 minus 1. It's 1 by 902. How much is this?
D. 0.0111 something. So it's 0.0011.
0.001, right? So it's option
Yeah,
A,
sorry.
right?
So it's A. It's A. It's A.
Yeah.
Yeah, that's what I meant. I got that.
Is that fine?
Yeah.
Okay. Now let's talk about power series. Don't confuse power series with the P series. P series is different. Power series is different. Okay. So when you write a kind of infinitely long polynomial equation like this, that means it's never ending. Okay, it goes to infinity. Then these kind of series are called as power series. Okay, and this is abbreviated as, writing it as summation a k x to the power k, and k is going from 0 all the way till infinity. So you can abbreviate this like this. So whenever you come across such a term, it basically should remind you of a power series. Okay. Now, it's not necessary that the power series is always in terms of x. You could have a power series like this as well. So there's something like a0, a1x minus a given constant, let's say a2x minus a square, a3x minus a cube, and again it will go to infinity. Okay, this is also a power series. This is called power series in x. This would be called as a power series in x minus a. Okay, this is very important for us to understand power series, because there are two power series which we are going to deal with. One is called Taylor series and other is called the Maclaurin series. We'll talk about it. First, try to understand.
So the previous one, is it a to x cube or a to x
I'm
square?
sorry, a to x.
Okay.
Slip of the pen. Sorry, yeah. Okay. Now, even for such series, we need to find out the convergence and divergence. That all depends upon what is your x, what is the interval in which your x is lying. Correct? So there is something called the radius of convergence. Now we'll talk about a very important concept which is related to power series convergence, which we call the radius of convergence. That means under what interval can your x lie so that this given series, even if it goes to infinitely many terms, is a convergent one. Remember here, all the AIs are constant. A0, A1, A2, etc. They're all constants. Okay. Now, in order to explain you the radius of convergence, I will like to take a simple example so that it's clear to you what do I mean by radius of convergence. Let's say I give you a question. Find all values of x for which find all x for which 1 plus x square all the way till x to the power n converges. Okay. So this is also a kind of a power series only. Correct. Now, do you remember the ratio test? Do you remember the ratio test?
Yeah.
Now here, I will take the, what was the ratio test? Can you recall for me?
Limit n tends to infinity, an plus 1 by an should be equal to L. And if L is less than 0, less than 1, sorry, it converges. L greater than 1 diverges. L equal to 1, you don't know.
Very good.
It fails.
The test fails, correct. Now here, since x is involved, as I told you, mod will be very important for us. Because x can have positive negative sign. So I don't know what is the nature of this, because we don't know whether it's a positive series, whether it's a non-negative series or whether it's alternating series. I don't know about it. So it is suggested that when you are applying the ratio test to such terms where the nature of the terms themselves are not known to us clearly, whether they are positive, negative, alternating, it's advisable that you take a mod over here. Okay. Now, a simple question I would like to ask you: what is the limit of n plus 1th term, which is x to the power n plus 1 by x to the power n mod, going to be? You'll say simple is going to be mod of x. Correct?
Yeah.
Right?
Yeah.
Because anyways, you're going to lose all the n's and going to just get a x left. Okay.
Yeah.
Now you're saying that if it is less than 1 only, it will converge. Correct? And you want it to converge. So what will you say? You'll say mod x should be less than 1 then.
Yeah.
That means the interval of x that you desire for the series to be a convergent should be minus 1 to 1. This will be your radius of convergence, or you can call it as the interval of convergence, whatever you feel like. Okay. So many books will say the radius is, they'll call 1 as the radius of convergence. Okay. So normally it is defined as, radius of convergence is defined as this value r. R is called the radius of convergence. So here 1 will be called as the radius of convergence. And this would be called as the interval of convergence. Okay. So the moral of the story here is that you will be given a kind of a series and you need to just figure out if the series converges for this or alternately if your series diverges for this, correct? So if it converges for this value, or you say this diverges for mod x greater than r, then r will be called as the radius of convergence. So that critical value r is named as the radius of convergence.
Yeah.
Okay. So let's try to find out for other examples as well. For what value of x? For what value of x does this series converge? Again, ratio test.
Yeah.
So limit n tending to infinity mod of an plus 1 by n. That's going to be x to the power n by n plus 2 divided by x to the power n minus 1 into n plus 1, correct? Okay. So this becomes limit n tending to infinity, and you can take n plus 1 by n plus 2 this thing, and you can take a mod x. Okay. So as n tends to infinity, this limit is going to be 1, right? So it's going to be giving you again mod x. So if mod x is less than 1 according to the ratio test, the given series would be convergent, else it will be divergent.
Okay.
Is that fine?
Yeah.
Okay. Now, very important thing here is to note that this tells you that x should be between minus 1 to 1, right?
Yeah.
That means it is not allowing you to take the value of 1 right now. But if you see, if you put x as 1, what do you get actually?
You will get 0.
1.
Let's say I put n as 1, what do you get? You get a half minus 1/3 plus 1/4 minus 1/5 and so on.
Yeah.
When you put x as 1, this is what your series becomes, isn't it? Yeah. It's an alternating harmonic series.
Yeah.
And we have seen that it is conditionally convergent.
Yeah.
So your answer would be slightly modified here. Instead of saying minus 1 to 1, you would say minus 1 to 1 including 1. This will become your answer. Are you getting it?
Why? Why?
Do we always have to substitute the values and put it?
No. In certain cases like this, you need to just do a check at the corner points.
Wait, so how do you know to check it or not? Like,
in certain cases where you have a feeling that this is going to become a harmonic series which is alternating, then you should actually make this check. Okay. And again, with a lot of problem solving, you'll come to know. But do I put a minus 1 in this?
no.
If I put a minus 1 in this, I will get something like half,
infinity.
1/3,
No.
1/4, which is actually a harmonic series.
But it's divergent.
Yeah, but this is divergent. So it is correct not to include minus 1. But 1 can be included because 1 will give you a case of an alternating harmonic series.
If we put -1, the denominator will become 0. Oh, x. Sorry, my
X
bad.
value, not n
Sorry,
value.
so
X
sorry.
value. Let's take more questions.
So basically, it's so that we know to include 1 as well.
Yes. Be careful about such questions. But there are some questions like the one which I'm going to give you right now. Let's say x to the power n by n factorial. Okay. For what value of x? For what values of x does this series converge?
So won't it become like 0?
Yeah, absolutely.
Won't? Yeah.
So it's always convergent?
Yeah, I guess.
Absolutely.
Yeah,
it's always convergent. So if you do that ratio test, limit n tending to infinity, mod x to the power n plus 1 by n plus 1 factorial divided by xn n factorial, this would lead to limit n tending to infinity
x by n plus
x
1.
by n plus 1, right?
Which
is
is
actually a limit of n tending to infinity mod x by mod n plus 1. And no matter whatever finite quantity you have over here, because of this heavy base over here, it will become a 0. And 0 is less than 1. So this will be always a convergent series. Next question. For what? Find all x. Find all x. That means find the interval of x. For which the following series converges. For which the following series converges. The series is like this: 1 plus x minus 2 by 2 factorial, x minus 2 square by, I'm sorry, not 2 factorial, it's 2 to the power of 1 by 2 to the power of 2, x minus 2 whole cube by 2 to the power of 3, and so on till infinity. So instead of giving you a general expression in summation form, they have actually written it down for you so that they can check whether you are able to write the nth term or n plus 1th term like this.
What do you have to say? So it converges, right?
For what value of x does the following series converges?
So is it minus
x
3
less
by 2?
than 0?
Minus 3 by 2 to 3 by 2?
No.
Is it 0 less than 0?
No.
Oh wait. So -4 to 4.
-4 to 4 is also not correct.
Is it less than minus? Okay, not minus.
So it's -4.
See, if you write the ratio of n plus 1th term,
x minus 2 to the power n minus 1 by 2 to the power n minus 2. So n minus 1.
that doesn't make a lot of a difference because cancellation of terms will happen. Okay. So that would leave you with mod x minus 2, correct?
Yeah.
By 2.
By 2.
Yeah.
By 2 is less than 1.
Now this should be less than 1. That means mod of x minus 2 should be less than 2.
Yeah.
That means x minus 2 should lie between -2 to 2.
2.
That means x should lie between 0 to 4.
0.
Oh, okay. Yeah, that's what I meant. So I just didn't do the thing. So yeah.
Is that fine?
Mm-hmm.
Okay. So I think I would need one more class for to finish up the series sequence chapter, because we haven't yet started with Maclaurin series, Taylor series. So one more class would be needed. So we can have it, I think, tomorrow.
So same time tomorrow.
Same time?
Yeah.
Would that be fine? Same time would be fine with you guys?
Sorry?
Same time would be fine with you guys?
Yeah.
Yeah.
Okay. Fine then, over and out from my side.
Yep.
Bye-bye, good night.
Bye.